Hey all, it's Andrew Couch here. In this Tidy Tuesday video, we're actually not going to look at this week's Tidy Tuesday dataset. I believe it's on Caribou. However, instead, I was actually reading your guys' comments, and one of you asked me to make a video on how to make many models, or essentially nested models. And I thought it'd be fun to do this. I opened up the R4 Data Science textbook, and I thought it'd be fun to go through their chapter on many models, specifically on how to make many linear models to explain some trends in this data set. I also thought it'd be kind of fun to go and apply the TidyModels to the many models tutorial. And we're actually going to use the same data set, which is Gapminder. Additionally, you may notice that this video looks a little bit different. However, I just wanted to basically film this on my laptop just to make sure I could do this while I was traveling in case I wasn't by a desktop. So we're gonna just use my laptop for this Tidy Tuesday, but it should all be the same. So we're gonna look up the Tidy Tuesday, uh, Tidy Tuesday, and then I'm gonna make this a little bit bigger. We'll zoom in a little bit. Okay. Oh, actually, just I need to not use a shiny document. I want to load up a markdown from templates GitHub document. There you go. Okay, sorry about that. Okay, so we're gonna delete all this garbage. Name this Tidy Tuesday Many Models. Oops. And then load in, let's see here, Tidyverse, TidyModels, the Broom package, which I think comes with TidyModels, and also Gapminder. Okay, so I think we got most of that stuff. Let's see here. Maybe we didn't run everything. Okay. Cool. So Gapminder is basically like a bunch of countries. We can kind of look at some summary statistics by just doing some counts. So let's count first uh, country, continent, and that's basically it. This is a pretty narrow data set where there's only about 6 columns that we really need to look at. So Gapminder, count country. We can see that there's 142 countries. If you count continents, we can see that there's 5 continents included in this data set, where most of the countries or most of the data comes from Africa. Cool. So what we're actually gonna do from the R4 Data Science um, was it package, our textbook, we're gonna look at Gapminder, and that's basically and instead of doing some predictive modeling, we're actually gonna try to analyze residuals. So one way to use models is basically figure out what can't be explained with the given features. So in this case, they use just linear models to basically explain this linear trend, and then they have the remaining pattern, which is the residuals um, with years. So that's the stuff that they can't really explain with the given, you know, with the given GDP per capita and stuff like that. So let's start doing that. The baseline thing we should always do is just let's create a baseline model. So let's do linear model predicting life expectancy with the Gapminder data, right? And then we have a baseline model, and we have that stuff. Additionally, what we should actually do, what we can do is we can use the Broom package and do a tidy function on it. In this case, we can look at all the coefficients, the p-values in a clean fashion. We'd also use the glance to look at summary statistics of this model. So R squared, adjusted R squared, AIC, BIC scores, stuff like that. And finally, which is probably the most useful, is we can use the augment function, which will basically use our baseline model and predict upon our data set that we trained it on, and we can actually look at the residuals, which is right here. So if we use the augment, we can do ggplot, AES x equals year, y equals dot resid, and then we could do like a geom, I don't know, point, and just kind of look at the chart. All right. So we can see there's, a decent amount of data that cannot be explained with our given model. Okay. Cool. So what we should be really looking at now is when can we apply nested models or many models? And the idea with nested models or many models is we basically use we pair it with two main functions, a group by, and then so we can do a group by, and then a nest. So we already basically know what group by, so we're gonna just say, we're gonna make groups of whatever factor or whatever categorical variable, but the nest will basically consolidate whatever group by function into a data set. So if we actually use the nest function without using group by, it just makes a listed tibble, and this tibble is our actual Gapminder data. So when we apply the group by and then the nest, we basically have little subsets of data for each continent, and that can be pretty useful when we're trying to make many models. So when we do this, we also have to decide, what do we want to group by? We could group by continent, which is about 5, or we could group by country, which if we look at here, minder count country, we see that there's 142 countries. So it'd be kind of cool to let's make 142 models and do that. But I personally don't think it's a good idea to make too many models. One reason why I was a little hesitant to make this video is I really don't subscribe to the fact that a lot of times many models will help you. In this circumstance, many models is basically used not as a prediction problem, but more as a analytics problem. We're trying to figure out, okay, what can't be explained by a model, which can be useful. However, since we're going to also incorporate TidyModels, I think it's important to realize that a bunch of nested models or a bunch of models fitted for each factor can result into overfitting. So with that being said, I think what we should do is actually group by continent and make many models for each continent, or make a model for each continent, which would result into 5 models. Okay. So first we have our baseline model, and now we can create a baseline model for each continent. So how can we do that? Well, we already have our data, and basically what we want to do is we want to create our baseline multiple times. And we could just do it where we could do a loop, or we could do some filters and just do this process over and over again. But luckily, the tidyverse has a map function. So we can do a mutate, and we can create a model, and we can do map. And we give it, and the map function has a .x and .f, which basically has an input and a function. In this case, our input will be data. And now we have to figure out a function. And there's 2 ways to do it. We could just do a, the F word. We could just make a function. Function. Do that. Could do a function and just say lm life expectancy data equals x, right? And that basically says we're going to use this function and apply it for each data and create one little model, right? That's pretty straightforward. Additionally, what we could do is we could just create a helper function, say create baseline model, and we'll give it a x, and we'll just say lm life expectancy data equals x. So these are the same thing, but in my opinion, it'll look a little bit cleaner. So if we do this, and we just kind of delete all this garbage and just say create baseline model, it'll do the same thing. So what I would recommend is saying This probably is the better. This way is a better way. It's important to make functions readable. It's important to make your code readable, and to name your functions to what they do, what they're actually doing. You don't need to make it super technical. You just want to say, well, we just want to create a baseline model, and then they can look at the create baseline model function, and they can say, oh, you just use the linear model function, and you're trying to produce predict life expectancy with whatever data you throw at it. So we're gonna do that. So now we have our models. We can also do another function where we can say map, where we can do a mutate and say results equals map model and then augment, I think. Let's see if that works. Okay. And now we have our results from the model. Specifically, what we're basically doing is we're going to predict, we're going to give it the, we're going to use our models or our many models and then predict upon the data that it was trained upon. And we can actually look at the residuals. So we're going to do that. We're going to select continent and results. And once we have that, we still see that these things are still listed tables. Luckily, there's a simple function called unnest. So now we have all of these data sets that are just unnested out or kind of like spread out. I'm just going to do a ungroup, and then we're going to select continent, year, and .resid. Right? And then we can do a simple ggplot. AES, x equals year, y equals .resid, plus geom, we'll do point, plus facet wrap by continent scales equals free y. No, we'll do scales equals fixed for now. What else do we want to do? We probably want to throw in a color. So color equals continent. Okay, let's see what that looks like. Okay. And now we can see something. For one thing, we could actually do a alpha equals 0.1 and maybe do a geom smooth. Okay, so we can see how our models definitely are a little bit different. We could also actually not even do a facet wrap. Let's see how let's see what that looks like. Yeah, that looks, I'm not really a fan of that. Okay. So we can see how with Africa, it's there's much more residual noise, right? The residuals are more spread out compared to say Oceania, Europe, America. So if you look at Americas, Europe, and Oceania, I don't really know how to pronounce that very well. I'm sorry if I'm butchering that, but we can see how basically these three countries are it's pretty easy to explain the life expectancy. However, with Africa and Asia, there may be more factors that we might have to introduce, or maybe more factors that we're missing. We're missing more context behind it, which is pretty interesting to do, right? So yeah, so that's a basic. So this is like basic many linear models for each continent. But one big thing between this is, okay, well, how can we do this, but with more complex models? Like, what if you wanted to do something crazy where, oh, let's do a bunch of boosted models? I personally wouldn't do that, but what we could do with TidyModels is we could start adding interaction effects for each country or each continent. And one good model that we could use is a Mars model, or the multivariate adaptive regression splines, and they can basically find these interactions for you. When I was my previous video on interactions, we mostly did linear model interactions using the recipes package, but I figured let's just create mini Mars models and see what that does. Okay, so we're gonna do that. Okay, so first what we have to do is kind of think about how we're gonna approach this. Well, with Mars models, with any tidy models, what we're gonna need to do is basically create a recipe for all these models, because there's a bunch of dummy variables. Okay, so let's first do that. So we'll just say, okay, we'll make a Mars recipe, and the recipe will involve life expectancy, and the data will equal to, in this case, since we've been saying x, we'll say x, and just to test out these functions, we'll just assign x to the Gapminder data set. Actually, no, let me think about something. Actually, we'll just do Gapminder. Uh, let's say filter continent equals. Let's say Americas. There we go. So and then we'll say select minus continent. Since I'm thinking we'll just do it the continent uh level models. We'll just create a single um model for the single continent, if that makes sense. So we're gonna do that, and we're gonna assign it to x, just so we can kind of test our code as we go along. Okay, so we have a Mars recipe. Our data equals x, and we're just gonna say, we'll step normal. We'll do a step normalize, and we'll say all numeric minus all was it outcomes, and step dummy, and then we'll say all nominal. So if we look at our Mars recipe, and we prep the recipe just to see what it does, and we can say that it did centering and scaling for year, population, GDP per capita, and then create dummy variables for the country, and that's what we want. Okay. Additionally, what we could do, which is a little bit more advanced, is how are we going to tune the model, and how are we going to tune the model for each continent. Maybe each continent will require different tuning parameters, right? And that's something where it's something where machine learning really becomes an art, where you kind of have to decide and make these arbitrary decisions on how it fits with the data. Or if you're a researcher, you probably know more than I would. So you could either do more of just kind of a test it and see the results, or you could read a bunch of academic journals and figure that out. But in this case, we're gonna do, because it's probably the most easiest way to do it, especially if you don't have a lot of domain knowledge, is just do some classic caret k-folds cross-validation tuning. So that's what we're gonna do. And we're gonna say Mars k folds. Actually, let's see here. Try and decide if I want to. You know what? No, we don't need to do that. So Mars k folds, and then we'll say v fold cv x. Cool. And then yeah. So one thing, what I was thinking about is maybe I should split in the train and test sets. However, since we're not really using this as a predictive modeling problem, we're really just using this to do interaction effect modeling, and specifically figuring using interpretable models to figure out and analyze the coefficients. We really don't need to worry about data leakage. We're just using the k folds to essentially find the correct parameters that we want to use it for. Okay, so what else we need to do is make a Mars model. So we'll say Mars model, and we just say Mars, right? Mars, yeah. And then what we want to tune is the number of terms. In this case, we're going to let it decide, and we'll say prod degree, and we'll let that tune. Set mode to regression, and then set engine to Earth. And I'm pretty sure Earth is the only engine you can use for Mars models, but I'm not sure. Okay, finally, now we actually have to make a grid for our k folds to tune it on. So we'll say Mars grid regular, and then we'll give it the parameters for any Mars model, and our levels will be 10. Cool. And if we look at our Mars grid, Mars grid, we can see that, okay, it's pointing like this is how many terms we want, this is the degree, yada yada. Okay, so now let's create a workflow. So Mars workflow, add model, Mars model, add recipe, Mars recipe, and boom. And then finally, what we're going to do is we're going to start creating our results from our tune grid. So Mars res, Mars workflow, tune grid. Our resamples will be the Mars K folds. Our grid will be the Mars grid. And our metrics, in this case, I think our metrics should be MAE. I think that's the best, mean absolute error. Additionally, we could do RMSE, but I think mean absolute error is the easiest thing to interpret, and it can kind of suit as residuals if we really wanted to kind of look at it. So, and then we're gonna do that and run the model. So I'm gonna pause it, and we'll come back to see if it actually worked. Okay, so the Mars models fixed came out, and we can kind of do the collect metrics thing. However, we already know the best way to do it, so we'll say Mars res select best, and we'll say MAE. And we can look at our Mars tune. Mars tune. We'll see 5 terms with a product degree of 2. Cool. And that's like, I think product degree is basically the way how we can determine the order of interactions. So this is like a second order interaction with 5 terms. Great. And then what we'll do is finalize our workflow by doing Mars workflow, finalize workflow, and we'll say Mars tune. Right. And then we'll make our final model by doing final model, and we'll say fit Mars workflow with our X, which is our Gapminder data, and it'll create a final model using the entire data with the given parameters that we used a k-fold cross validation on, and it'll also save the recipe, model, and yada yada. So we'll create a final model that we can actually use in our final many models function. So I'm going to do that. And we have that. So final model. Cool. I think we also use like predict final model on X, right? And I'll give our predictions right here. Great. So that's all said and done. We kind of have our entire thing that we want to do. So this is saying that for each, if we actually look what we're trying to do, so I'm going to bring this in. So we'll say create Mars model function. So basically, for each data, each continent's data, we're going to basically create, split the data into 10 folds, or in 5 folds, I think, 5 folds, tune a model with 10 different parameters, figure out the best parameters using each fold, given by using the best MAE, and then we're going to train the final model using the parameters on the continent's data. So it's going to reproduce this entire process 5 times. Okay, so that's what we're going to do. Another thing that we should also add is the cat function, and we'll say model completed, and it'll just print off model completed, and I think it's -n. So if I do that, those two, model completed. So we'll do that. So what are we gonna do? We're gonna basically create a Mars function. So we'll say create Mars model function X, boom. Okay. And then we'll return the final model. Great. Okay, and I'm actually gonna make sure to delete what is it? Oops. I'm gonna delete all this stuff. just to make sure I don't have any leakage. So I'm gonna rerun that. Actually, I'll just do this little thing. I'll just run all chunks below. Should be pretty fast. I'm not too worried about it. Okay, and now we'll say train nested Mars models. Okay, so we'll do the Gapminder group by continent. Oops. Group by continent. Nest it. And then finally create our model, which is our create Mars model. And we have to use the map function and say data and create Mars model. Boom. And we'll say many Mars. We'll say Mars model. What do we call it? Mars models. Okay. So once we have that, we're gonna run it. And once the first create model created pops up, I'm gonna go and pause it and let it run, because it's essentially doing training up like 5 models for each continent, tuning it, and then fitting another one. So it's like 6 models are being fitted times 5, so it's about 30 models are being created, which is pretty fun. So let's see it do it. Just trying to wait. What else can we do? Okay, so this is taking a little bit longer, so I'm just gonna pause it, and we'll come back when it finishes recording or finishes modeling. Okay, so you can see how the model completed showed up 5 times, which means all of our models were successfully trained. Ugh, that's hard to say. And we see continent, data, model. What we also want to do is, since we have our models, we want to actually analyze our residuals and then plot out per year. So that's what we're gonna do. We're gonna do we're gonna use a mutate, and we'll say results equals map 2, because we're gonna use 2 inputs. In this case, it'll be our model, our data, and what and the function will be predict. So you can't. I don't think you can. When you're using map 2 or pmap, which has more than 2 inputs, it's kind of important to figure out kind of like, I guess, the logical order of it. So if you do data and model, I think it'll run into errors. Yep. So it's probably important to be a little wary of that, but you know, you can switch it around and you'll have you'll be fine. So now what we're gonna do is select continent data and results, and we'll do a unnest. Right, so now we have our prediction for our life expectancy, and then our year thing. Cool. And then we'll do a ungroup a ggplot AES x equals year, y equals, oh, actually just that. We also have to do is create the residual, so mutate resid equals life expectancy minus dot pred. Right, actually, I'm pretty sure that's how residuals are calculated. Let me check it out. Residual fitted. Where's the 28? Yep. Yeah, because it's 28.8 minus 28.8 minus 28.3, so it should be 8.4. Which, okay, that's right. So I was right. Okay. So mutate residuals, and then we'll finally do a ggplot. So ggplot AES x equals year, y equals resid, color equals continent plus geom point alpha equals 0.1 plus facet wrap by a continent scales equals fixed. Boom. And we'll do was it a geom smooth s equals, and then we'll say yeah, geom smooth, and throw that in there. And we can see that it definitely tells the same story. However, we actually have accounted more for Oceania than I think for Europe. Let me actually bring it back down. Yeah, bring this one. Yeah, we'll just bring that down to just for some comparisons. Okay, so you can see that they basically did the same thing, but uh, but we get a little bit different results, and um, we kind of learned more on how to make multi-level models. I know this was a pretty quick video, but I think it was kind of fun to do some more tidy model stuff. And if you guys want to do, if you guys have any more suggestions for what you guys want to see for next week, just comment, and I'm sure I'll make a video on it. So yeah. Anyways, I'll see you guys next week and tidy on.